some of the stuff we talk about here is applicable to question 1. For instance, for part A, using Bn to represent the balance of the loan after n months, write down a recurrence relation to model this loan situation. Now, you have to start off with B naught is equals to $1,100. That's the beginning amount, yeah? And then we know that it's going to take up a loan. The interest is 9% per annum, compounding monthly. Okay, and we want it to be repaid with 6 equal monthly payments of $190. We'll use this information in the next following questions. Now, to answer part A, B naught is the first thing that you need to do. You know that every month, every payment cycle is paying off $190. So you're paying off the loan. So it's minus 190, okay? And Bn plus 1 is equals to the interest rate, something to do with the interest rate here, times Bn, the previous amount, okay? And then take away 190. Now, to calculate the interest rate, the whole number 1 represents 100%, but you're borrowing money, so it makes more sense that the amount that you have to pay back to the person or place that loaned you the money should be more than 100%. So in order to work out the interest rate, we have got 9% divided by 12 because it's compounding monthly. So R is equals to 9 divided by 12, which is 0.75%. Now you need to change it into decimal. I know that it may be confusing because you would argue that 0.75 is a decimal, but the point here is the percentage sign makes this a percentage, okay? So even though it looks like it's already in decimal, but when the question asks you for decimal, for example in question 1, then you still need to convert the percentage into a decimal amount, because then we can use it. 1 plus capital R, 1 plus 0.0075 gives you this value here. Part B, determine the amount of the final payment correct to the nearest cent. Nearest cent. Okay? Need to round it to the nearest cent. Now, interest is equals to $177.52 times 0.0075 because we are looking for interest only. So, this one, this box. And the interest is payable on the outstanding loan. In this particular case, the outstanding loan is the previous balance of loan, which is 177.52. And the interest rate for each period is 0.0075, like what we've worked on or what we've worked out previously. Okay, that's how you got the interest. Now, the final payment should be slightly less. You want to pay it off within 6 months, right? So on the last month, if you work it out, the final payment would be whatever the balance of loan and 1.33, because 1.33 is the interest amount. So at the beginning of the final month, you've got 177.52, which is the principal amount, and you've worked out that for this amount of money at this interest rate, that is the interest charged. So the final payment must cover whatever that you still owe by the end of the 5th month and the interest charges on top of it. So it's 178.85 rounded to the nearest cent. Now, what's the effective rate of interest? Effective rate of interest. this is the formula. The 12 here is because it's compounding monthly. If it's compounding daily, it will be 365. Okay, get it? So our actual, the actual interest rate is 0.0075. So you put that value into R actual in your formula, you'll be able to get this answer. And then correct to 2 decimal places. 8 is the second place after the decimal point. So you're looking at 0 to decide whether you round up or round down. So 0 is less than 5, you don't round up. Since a lot of you haven't really done enough revision, especially in the financial maths segment, so I thought I'll throw in an additional question in my explanation. So question 3, you can see that in our sec we already looked at a lot of instances or examples of using this particular table to help you use the financial solver on your calculator, right? The thing you need to remember is this bit. Now, remember we talk about what using yourself as the point of reference. So if you are putting money in a bank to save it up, the money has left you. It's no longer with you in person, it's with the bank. So you will have to put in a minus, okay? So in the future, when the money comes back to you, okay, it's George wants to have at least 750,000. So that's what goes into here, okay? And your money is coming back to you, so it's a positive value. Most of you got this correct, got the interest rate correct, got this correct. Some of you get this one correct. Unfortunately, most of you, if you put in 350,000, you forgot the minus sign, so your answer turned out to be wrong. Okay, so please remember, use yourself as a reference. Whatever money that's left you, put a minus sign in front. Whatever money that's coming towards you, use a positive sign. Okay? Part B is a trick question. They are testing your understanding of the word perpetuity. Now, look up your textbook, but I'm pretty sure I remembered this correctly. Okay? So perpetuity is the option, investment option, where you just use the interest being paid on your savings. So you don't touch the principal amount. It stays with the financial institution forever and ever. You just spend the interest portion. So how much will remain in the account after 5 years of retirement? It would be the original amount because you wouldn't have touched it at all. Okay? Now question 4 is similar to part 3b. His big brother has borrowed 350,000 to buy a house and will pay 2,600 per month for 20 years. Blah blah blah. Now, he wants to look at half the monthly payment but pay every 2 weeks per fortnight. So 1 year 12 months, 1 year 26 fortnights. Okay, if you think about it, we normally say that 1 month has 2 lots of fortnights in it, but then the maths doesn't work out because 12 months, 2 lots of fortnights within each month, that should give you 24. But in actual fact, we know that 1 year has 52 weeks, which means there's 26 lots of fortnights because you have to half the 52. Okay, so you're actually paying extra time. You're actually paying the 25th payment and then the 26th payment twice more. So if you do the calculation without even worrying about anything else, the interest rates and all that stuff to confuse you, 12 months you pay 2,600 per month, so 12 times 2600 is this. Fortnightly, you've got 26 payments at half the amount, which is 1300. Then you've paid this much off.